it out there for everyone. So let us know if there's any problems. But thank you, Carson.
All right, no problem. You're also tired. I'm gonna start with some fun questions I just came up with right here. So how many people are going to KubeCon? Anybody? Yeah. I submitted a talk, not this one, but a different one. 900 people submitted talks apparently, so we'll see if that actually happens. But and then how many people have used RBAC with Kubernetes? Okay, cool. Well, let's get into it. So my name is Carson Anderson. I'm with Domo. If you couldn't tell from all the swag, this is my GitHub in case you're curious. On there occasionally submitting PRs to random open source projects. Here's kind of my plan. We're going to start with just an overview, what it is, why you might want it. We're going to go through enabling it, using it, a couple different ways of debugging. Some ways that I found are kind of cheap but effective ways of debugging. Tips. I'm going to kind of breeze by the how-to. I'm going to try to cover a little bit in depth, but not spend a ton of time going over every possible scenario because the RBAC documentation is good. It's really well fleshed out. If you have any questions, they're like, how exactly do I do this or that? There's usually a lot of good examples. So I'm going to give you enough in the how-to to like get the gist of it, but not go into tons of detail. Because I want to spend most of like what I learned as we went through, and then kind of some live like debugging and introspection. It's not super heavy on the live demo, but I do have some. So overview, role-based access control, RBAC. This is actually, by my count, the second or third authentication or authorization method. I'm not going to go into authentication at all. That's an entirely different discussion. I'm going to assume you have some sort of users and groups set up somehow. And even if you're not using any of the fancy like OID auth or any of that stuff, you still have service accounts, which are essentially dynamic users. But I'm not going to go into that. I'm going to assume we're talking about that. Before RBAC, there was access-based access control, just as a bit of history, which was super static. You gave a JSON file to the API server when it started, and it loaded that, and that was all you had. And if you wanted to change it, you had to reload. I don't think anybody's really using access-based. Maybe they still are out there, but RBAC is really awesome. It's a deny by default, which is the exact opposite of normal authentication. Right? Normally, the Kubernetes API server, if you're not using some sort of authorization layer, you can get to anything. It's all open by default, including all of the normal default service credentials that pods get, whether you know you're giving it to them or not. We'll go over that. It's a way to assign permissions to the consumers. It's loaded dynamically. So anytime you add resources, update resources, delete resources in the API server for all the resources we're going to talk about, you don't have to do anything. It's just applied, and it's applied really, really quickly using the log watches the API server uses. So it's basically there to secure the API server, which instead of being open by default, it closes it up. Starting 1.3 was alpha, and in 1.6 and on, it's beta. It's still beta. I don't even think 1.8 has it coming out of beta, but I mean, deployments are in beta, and pretty much everyone uses those all the time. So I would not let the alpha beta thing stop you from using it. It's really reliable. I think Kubernetes is just really slow to take anything out of beta. So enabling it, like I'm going to stand up here, like pretty much everything that you do in Kubernetes, you change whether it's on or off by changing command line parameters for a component. In this case, the component is the Kubernetes API server. This is where we have it. It may be different. You may not even have a YAML file to edit if you're doing Minikube and some other things where you give these options via environment variables. But you'll find somewhere where all these API server environment variables are being set, or the options are being set, and you just add the authorization mode RBAC on top of it. The two things here, the top one turns on the API resources so that you can create, add, update, delete resources in the API. The second one is what actually turns on that layer. So if you have an existing cluster, you're not lucky enough to be able to like bring it down for a while you figure out your roles, you can turn on the API, just the API resources, start putting your roles and everything in there, but not actually block anything yet. Mostly I put them on at the same time and just kind of figure out what's broken, and we'll walk through how you do that.
Yeah, I think that's a list too, and it's part of it, right? Let it drive.
Yeah, so runtime config, you might have stuff in there. If you do, just comma separate, add more, and that's unordered. Authorization mode, if you have stuff in there, it's left to right, fall through. So you usually want to put RBAC. If you have something in there called always allow, put RBAC in front of it. And if you have always deny, make sure RBAC is actually in front of that too, right? You probably want it somewhere near the front. The really cool one is an aside that goes with RBAC, and I wish I had time to talk about it, is node per node authorization, which is fantastic. I haven't even implemented it yet, but I love it. I love the idea of it, which is where you use RBAC plus every node gets its bonus TLS client certificate, and it can only get API resources for the exact things that are connected to it at any point in time. Right now, even when you turn them on, the default roles that they have, because they're all coming in as one user, just give them access to pods and secrets and whatever. So maybe that would be another talk when we talk about node authorization. I think that's really important coming up. So you just turned it on with those options. Two things just happened. First, you got a whole bunch of new resources enabled in the API. You got roles, role bindings, cluster roles, and cluster role bindings. We're going to go over exactly what all those are for later. You also got the API server, when it comes up, it's going to create a bunch of default system roles and service accounts. And everything that it makes, and again, this is not the comprehensive list, docs have that. It makes all of these and it keeps them in sync. So if you change the API server version and restart it, it's going to update these appropriately, unless you tag it not to. My recommendation is don't edit these, because you'll just end in sadness. Either it's going to change it out from under you, or you're going to lock it, and then something new is not going to work. But they're really great as source examples. I'll kind of show how to read some of those and use them as like, okay, well, what does the system think is a good way of having the API giving the node controller just what it needs. All right, so now the API server is locked down. Like I said, as soon as you turn on RBAC, you are default denied. Some of the core components are going to work because they're created by the API server. So your scheduler, your controller manager, nodes, node proxiers, like all that's probably just going to be fine. What's not going to be fine is any extra stuff that doesn't have the associated RBAC with it. So cluster DNS, if you've got fancy things in your cluster that talk upwards to the API, all that's going to suddenly stop working. What I did when I had to move some stuff over between getting the really good roles and having it all be broken was this. And we'll go over in detail exactly what this is doing, but I just put this in here as a reference. This basically says any pod running in the Kubernetes system namespace can just have cluster admin. It's what they had before I turned on RBAC. That makes DNS not break and a bunch of other things that are add-ons that you put in there not break. Then you can go in and assign more specific roles later and rip this out. It's just kind of like, I want to turn on RBAC, but I don't want to break the whole thing. This is a good way to jump in the middle. So now we're going to dive deep into what all of these are. I'm going to touch on service accounts because they've been in there forever, but they really had almost no use until RBAC. They've only actually caused problems, if you ask me, in a lot of ways. So service accounts, they've been in there since day one. Since day one, every pod you create, whether you tell it to or not, every time you make a namespace, it creates a default service account, maintains some tokens for it, and it sticks those tokens into your pod for whatever using the Kubernetes API libraries you use. And in the past, it's been full access, and that's been something that's blown people's minds. It's like, okay, you get onto any pod and you've got API credentials to the cluster, which is one of the reasons you really want to turn RBAC on. Like I said, when you create a namespace, it creates the default. Service accounts are per pod, not per container. And it's cool because they are automatically mounted into your pod. There's, I can't remember, bar, something, Kubernetes, there's CA cert, a token, and all of that. And all the normal Kubernetes API libraries know how to work for that. You can kind of think of service accounts, if you're an Amazon person, as instance roles. Like, they just work. If you're using the libraries, they know where to look and kind of fall down through the methods, and this would be the default credentials. Here's the imperatives on how to make those, and the YAML. These are super simple, but you'll use them a lot if you want to effectively use RBAC. So roles. Roles define a set of permissions. I'm going to go back to Amazon because I do a lot of Amazon. I don't know who else in here does, but they're a lot like IAM roles in Amazon. It's not who can do what. It's just the list of possible things that you can do. A role here, there's no imperative, note. There's no way to just qctl create role, and I assume it's just because we'll get into this. The syntax for this would be a nightmare if you tried to put it on the command line as an imperative, so it's just YAMLs. So it's a role, it's got a version, type, metadata, all that stuff you guys have seen. Here's the kind of the meat, where you have a roles list that contains groups of roles. API groups, here, when it's omitted, just means the core API groups, basically everything under version 1, pods, services, endpoints, namespaces. In this case, it supports globbing, so we're just saying all resources. So this role would say whoever got this role, the binding, would be able to get, watch, and list, whatever. Note that these aren't exactly the HTTP verbs, and that's because there's more. There's more than just get, post, in Kubernetes. There's some special verbs. These are various versions of a get. Obviously, the watch is like what a lot of things do, which is different than just listing all your pods, actually creating a long maintained watch on. They're scoped, so I'm going to talk about kind of roles and bindings in general, and then at the very end, we'll say what the scopes are for. But you can, the cluster role syntax is basically entirely the same when it comes to cluster level stuff. It's just going to be called a cluster. I'll kind of explain the difference later. So we're going to walk through a few examples. Again, the documentation has the meat of this if you really want the details. So if we're going to read the core resources and some examples of explicit core ones, this would be how you do that. All the same kind of boilerplate here. We're doing the core API group, listing out very specific resources, which don't match that list, but that doesn't matter. And just, again, those three verbs. And this is a bit different syntax. It's also a valid YAML from the one before. This is just kind of a longer version of that. The difference here, and you'll notice that deployments was not on this list. That's because deployments is not a core resource. Depending on your version of Kubernetes and how you're creating your deployments, it's going to be under the batch or extensions group. When we get into debugging, I'll show you how to figure out what in the heck group you're under, because it's not immediately obvious a lot of the times. You can kind of tell in your YAML, because it'll tell you what, when you have a YAML, you're going to put in there the API group as the API version up here. So you can kind of get that, or you can get it from the logs. But so here's where jobs and deployments are in a separate list because they're in a different group.
A quick question.
Yeah.
So I know they don't call them third-party resources anymore, but how does that,
Same syntax that grows for third-party resources the same way. You put in your extension, and I haven't used them, but there's no hard, there's no like validation on the content of it, right? It just has to be a string and match what you're going through. So if you put in, if you misspell this, it would still work. It just wouldn't. It'd allow it into the API, but it wouldn't work. But for third party, you would just put your resources in there with API group under. I don't know. It might actually be. If you looked at it exactly, it might be especially API group for third party resources. I really want to do some of those, but I haven't done it yet. A couple more gotchas. Non-resource URLs. So here's an example. The two big ones are help Z and version that you might get from the API server. Some of the things to do monitoring, or a lot of times just things running the cluster want to figure out what the version is. And this is how you would give it access to. I don't have version in here, but you can just do another list entry and say, oh yeah, things that have this role can get the version and the help status out here. And then here's another example of the rewrite on a separate group. So again, batch extension, we're giving all access to deployments. We're going to talk about access by a specific resource name. If you want to get really tight on your systems, you can say, all right, you can, in the core group, you can get secrets. You can do whatever you want with it if this is its name. Otherwise, nothing. So if you want to really lock down your pod, you can stack them all in one namespace and just say, yeah, you can get your secret. Sub-resources are also another gotcha. So it's core group, but it's pods / logs. Just giving people access to pods does not give them access to logs. So again, you can get that. I'll show you where that is in the debugging later to figure out like sub-resource. How do I even know if that's a sub-resource? So role bindings, which is how you actually use all those beautiful roles that we made earlier. They tie a set of users to a role. You'll notice here in the YAML that you define, it's a dictionary for the reference of the role you're going to bind, but the number of people is a list. So you can have an admin binding and then keep adding list entries and changing the list entries as much as you want. You have to, at a minimum, you have to have one per role, right? Like you couldn't put 2 roles in here and have one binding that binds users to 2 roles. It's additive only. All of the Kubernetes access control is additive only. It simplifies it greatly, in my opinion, where you have nothing, and it just goes down the list of things you're bound to until you get access. If you don't get access, you don't get it. There's no denies. There's no order to anything. There are 2 types, just like with roles. There's the cluster role binding and role binding. And those are scoped cluster-wide and namespace-wide. And we skip over that because I have a slide that shows that and how that works. The imperative example, so if you've got a lot of roles created, and you don't want to create the YAML, you just want to quickly bind users to specific roles, you can do that here. I'm not going to explain it, it's self-explanatory there. And then we'll kind of go over how the subjects are laid out. So, like I said, there's scope, where you can either be at the cluster layer, and you need to be at the cluster layer, more importantly, for cluster scope resources. So if you are at a namespace layer, create a regular role and a role binding, which are created in a specific namespace, and try to give people access to nodes, it's not going to work. Because nodes don't exist in a namespace. They exist in the entire cluster. Same thing with persistent volumes and namespaces, and who knows what else is going to be added. Pretty much anything that doesn't make sense for a namespace your scope. And then also there's the namespace scope, which has roles and role bindings, and has pretty much all the meat and potatoes. So here's the cluster scoping. Kind of try to make this self-explanatory here. So one of the really cool things about cluster roles, so we have this cluster role defined here that says you can get pods, get list watch. This is created at the cluster layer. If you bind that role to a user here, so for example, we're saying the pod reader service account anywhere and is bound to that with a cluster role binding, that means they have access to pods across the system. But notice here that we're referencing cluster role in a role binding. If you take that exact same role that's defined at a cluster layer, but create a regular namespace role binding to it, it's going to give them those, it's automatically going to scope them down to the namespace they're in, which is super cool. If you want to not have to recreate the same roles over and over again in every namespace and maintain them, if you're like, look, I just want some people, when I make you in this namespace, I'll let you read pods in it. And you make one role, create one role, and you just bind it at the namespace layer, which is, I think, really slick. It's really cool because you can actually use this plus the default roles that were made by the API server on start. If I go all the way back, right here, the cluster admin edit view are maintained and created by the API server on start, and they're cluster roles. So you can just bind those in namespaces, and you've got kind of some pre-made generic like view only admin accounts. And I thought I had more slides on the role binding, so I'm going to go over kind of the details of here. Let me check. I just switched these around. Nope. So kind of go a little bit more into the YAML spec here. Like I said, you've got the role you're binding to, which is once per document, and then you've got the number of subjects, which can be 1 or it can be as many as you want. Kinds here can be service accounts, users, or groups. And there's some special syntax for naming where you can say just this service account in this namespace, or all service accounts in this namespace, or users in this group. So it's super flexible, kind of just to do whatever you need to do without a whole lot of extra resources. Privilege escalation. You can't create role bindings or create roles or bind people to roles without having the same privileges that you're trying to give. So you can't, as somebody who can edit namespace, you can't go create a cluster role binding that gives you access to all the secrets in the cluster and then bind yourself to it. So there's an exception to that if you've been explicitly given bind access. So they've made this concept of you can create a bunch of roles, have some admin access controller guy who doesn't do anything himself, but can bind individual people to these exact roles to kind of work around that, where he may not have access, but he can give you the access. I don't see a lot of call for that. Honestly, I think most of the time, a lot of us just have one big cluster admin that is carving up sections, but if you wanted to write a whole infrastructure on top of this, you can. So, like I said, I'm breezing through that. The documentation in there is really good. If you have questions, let me know. We can go over the details, but I want to get to what I did when I found when I actually did this, kind of the problems. And the first two problems is like, okay, great, access control works. How do I tell what's failing without having to go look at everybody's logs? And how do I tell, this hit us a lot, how do I tell what Kubernetes components are doing? And you combine, you don't need RBAC, you technically, to do some of this stuff, but it really helps. So 1.6 and later, in the Kube controller manager, not the API server, you can turn on this use service account credentials. So you go edit it however you're going to, restart the component, and what you'll get is the controller manager, which is the main core control loop of Kubernetes. I explain it as that anytime you say Kubernetes is doing this for you, it's the controller manager. This is the only thing that's proactively doing anything in the cluster. The scheduler just responds to pods that show up. The API server is just listening for requests. The controller manager is the guy that said, oh, wow, that node's down, let me move the pod down, or you want 5 more of these, let me add those. And you'll notice, if you look at the code, or if you look here, there's every single thing has its own controller code. And when you turn that option on, every one of those creates its own service account with its own scoped permissions, depending on the version, it's various amounts of just creating them or actually like creating roles that are exactly scoped. So when you add a node, the node controller does stuff. When you run jobs, the job controller is the guy that makes pods, etc. And that's super useful when you combine it with the audit log. So what I did before the audit log was watch the API server. And you can look at the API server logs on if they're verbose enough, and you can kind of read what's going on, but there's a lot of stuff in there, and it's not really designed for auditing. This is the simple version, 1.7, I think 1.8, 1.7 has some more advanced options. You can really like tweak the audit log. I'm just going to go with the default. You know, tell the API server, this goes to the API server, like, here's where I want you to start putting your audit logs. And there's some rotation options and whatnot in there, so you don't have to worry about that. When you do that, that's, I think, the absolute best way to dig into and figure out, like, all right, first of all, what's doing anything, but second of all, what's failing? What's getting errors now because RBAC is off? So here's my super cheaty. Do not use this as a like actual code way to do anything, but it works for debugging just fine. Way to get this, because there's two lines. If you notice the date lines here, there's actually two. There is the request coming in and the response going out. And so if you just grep for 403, all you're going to get is this bottom line. It's not going to tell you anything useful. My cheaty way is to look for 403 in quotes by itself, get the line above it, and again, this is not good for code because it could, you could get bad luck and have someone else's stuff get in there. But for regular debugging, it's fine 90% of the time, or 99% of the time. Just grep the first line above it. So here's an example of a failed request. We've got a 403 access denied. Someone was trying to go to deployment. This is where you can get the extensions. Those will go to API apps. That is the grouping. So there's the grouping and the version. The reason the core is empty is because there's no APIs, v1. There is no /core. Like that's why the core part was just an empty strings. It's the thing that comes between APIs and the version. So in this case, someone was trying to get deployments across the entire system, and it was this guy right here, this user. A service account in Kubernetes system called Datadog agent. You wrote this out when I was, yes.
So that says apps there, but you said the deployments belong to like batch and extensions.
Did I put batch in there?
Yeah.
Okay, I've been changing these a lot. So deployments have been in extensions and in apps. Batch was for jobs.
Okay.
So you're right, that probably would have not worked, that sample one that I pulled up. So yeah, in this case, yeah, deployments has been in extensions and it's also an app. So what should be for deployments should be all three. If I'm doing a rule for deployments and jobs, it would be apps, extensions, batch. So that's a good catch. I'm going to go to the next one, which breaks this up. Again, this is a single line, but I spread them out so it's a bit easier to read than that giant blob. If you're going to try to like figure out how to slurp these in your log file and like put in your logging system the right way instead of just guessing about the line above it, you match up these IDs. Take this ID, match up that ID, put them together, and you've got your full record. I think a lot of things have done, not tons of things like email server and other stuff have done these request response log systems. I tried like heck to find a Kubernetes plugin that would take these two and put them together. I couldn't find it. I feel like I have to write my own. That's stupid. But I mean, depending on your logging system, they may have a way to combine two records based on an ID. So again, here's where you can see the user here, the group they're running as. These as groups and as fields here would be fields that they were using the impersonate, which we'll talk about later. And again, there's where you would read the deployments out. So impersonating is a way to more proactively see if the user that you are trying to make permissions for can do a thing. Basically, if you're a super cluster admin, then you already have this, or if you want to grant this to extra people, you can. There's a special verb for it, and you can either say you can just do any of these resources, or you can limit it to, I can let this person just impersonate this one user, group, etc. And the way you use that is there's header fields that you put when the API requests, or kubectl just has it built in. Kubectl, I guess it's not supposed to call it. I'm going to try to retrain myself. So kubectl patch deployment, I'm going to run as the reader. I'm trying to put in some stuff that I can't do. And I'm going to get the response back. And then this is the debug line separately from that. So I'm doing the impersonate at the top, and I can like actively try to be this user and try to do a thing and see if it works. And if I wasn't actively and I was just watching the logs, I could see the same thing here, where I got a 403, someone's trying to, if it was me not impersonating, you would just see it as a normal user, but if it's impersonating, you can see it's someone trying to impersonate. So here's what happens when that works. I'm running as the admin instead of a viewer. I'm trying to patch stuff, and I get 200, and life is good. So I'm going to jump into a demo here. So it's just two connections to the same system. We normally run HA masters all the time, but what I did instead was turned off two of the masters so that all my logs went to one audit server so that it was easy to track.
Could you increase the fog?
Yes. That good?
Yeah.
Okay. So we're going to use that grep that I did earlier. Dash v1 before one. I'm going to grep for by itself. And you can do various versions of this that if you don't do the quotes and stuff, you'll get timestamps that have 4, 3, and whatnot. Log audit. And I put my audit log in a different place then. Okay. So you notice I'm grepping 403. There's not anything up here because this cluster has all its roles in order. Everything that's running has permissions. If I do this tail without the grep, tons of stuff is going to be coming through. So all sorts of goodness, and this is how you can see like what's going on in my cluster. And a lot. There's always a lot going on. Even if your cluster is doing nothing, there's a lot of stuff running in the background that's always working. So I'm going to put that back on there. And we're going to do some live debugging. So if I go right here, so if I change the dashboard, what I've made is I've made this, I've just taken the normal Kubernetes dashboard. I'm making a special service account just for the dashboard. Oh, that is, look. Can you guys read that? No, not really. I'll turn my coloring off. Maybe I should just go less. nuts. Okay. Different. All right, is that better? So making the standard service, a special service account just for the dashboard. I've taken the normal Kubernetes dashboard image, the really stock deployment here. And you'll notice right here, the special part of that is the service account name right under spec. Where I'm using the dashboard service account that I'm making up there. If you don't specify, it's just going to always put in the default. It's nice to give each one a service account so you can limit what each one can do. I'm making the ingress here. I'm going to point it to a subdomain of my own so that we can see it and see some errors. And I'm exposing a service for the ingress to use. So this is like the most boilerplate kind of basic thing you can deploy in a cluster. All right. Let's do this. Create namespace demo. And delete this from when I show this to my coworkers. Okay. So we go back to this. You'll notice I already got one. Without me even going to the dashboard, I already have somebody come up and fail. In this case, it was the dashboard coming up, and the first thing it does is try to figure out if Heapster is in the same namespace and help. So it's actually just going to Heapster in the Kubernetes services namespace, and that it doesn't have access, right? This is the dashboard not running a Kubernetes system where it already had access from other roles. This is a dashboard in a specific namespace. So let us go to RBAC. Can't remember what I called that. Dashboard. So if I pull up the dashboard in this other window, you're going to see all sorts of 403s everywhere. I'm serving the dashboard. I just went to it, but again, it's running in a brand new namespace, no extra credentials. Just it's trying to do all the things. If I click right in here, pretty much everything I go to, it's going to fail. So let's take a minute and kind of debug some stuff here. If I go to nodes, or refresh the node request, you'll notice that I have the URL right here, V1 nodes. It's not namespace. It's just right under V1. It's trying to get nodes at the top layer. If there's namespace, there would be /namespace, node /namespace. If I go try to get something like pods in the default namespace, it's trying to go to namespace's default and get pods. So that's something that's namespace. You can get pods, of course, on all namespaces, but and you would have to bind that at the cluster layer if you wanted to do that, but that's not what the dashboard does. It's getting only one namespace at a time. So let's go give it access to some nodes. I've got this dashboard, and I less it first so you guys can see it, because the editing is getting washed out if I don't move in. I'm not sure there's a way to turn colors off, but I'm off the top of my head. So we're going to create a cluster role. I've left a lot of this blank to go fill in, and then I'm also going to make a binding, cluster role binding to bind to the cluster layer. So, anybody know the color off command is in Vim? Turn it off. What?
Syntax something off. No syntax. There should be no syntax.
I think it's called Sublime.
Oh, sorry. All right, so we're going to say this is the core group. Again, nodes have been around for forever, so they're not an extension. We're going to add in nodes here as a resource. We're going to say we're going to get list watch. We're going to say that this is a service account.
Sorry, so what does get in this watch does?
So get is your standard, like I want to get one node. So if I already know the name of the node in advance, I can get it. I can get nodes in this one. List, lets me list all of the ones that exist. And then watch is kind of like a list that never disconnects. When you do a watch in Kubernetes, which is how all the great stuff in Kubernetes is done, basically you connect up to the API server, You say, I want to watch this resource. The first thing it does is send you everything that exists already, and you have to process it. And then you hold that connection open forever. And every time something changes on those, so if you're saying I'm watching pods, every time a pod changes, you get that event, and you can eat the pods one at a time. So there's no polling. There's no always trying to like get the whole list and figure out what's new. It's really, really powerful. It's how Kubernetes is super reactive and fast. It's basically a feature of etcd that they have, which is the backend data store. They've taken that watch feature and just pushed it all the way up to all the API consumers. So if you're doing polling and you're getting all of everything, you probably should look at watch because it's really a lot better. So I'm going to create the binding. The subjects here is a service account. I created a dashboard. Was the account I made, and it was in demo. And I'm going to bind it here. The reference is a cluster role that I'm making above, and the role name was this Kubernetes dashboard. I save that. Create that. And it's already there. I got to change the name. Okay. So I created this before, demo 2, but I bound it to the service account in the other namespace. So I'm just going to change this to demo 2. The names are unique. So it's going to make both of those. Now, if I were to go click list nodes here, and the demo gods are nice to me, refresh, and we should see nodes and no 403s. There you go. So it's walking through, like, why didn't this work? What's failing? We figured out what it was and added the associated binding. We can do the same thing for getting pods. So if I do that grep here, I try to get pods. It's trying to do a lot of things here, but I think the very last thing here is getting pods. There, you can see going namespaces, right here. So it's trying to get the pods, it got a 403. So the exact same scenario. Namespace. So here we're creating a role and a role binding instead of a cluster role and cluster role binding. Core namespace, pods. I'm just going to say you can go hog wild. Whatever, just glob it. This again is a service account. The name was dashboard. And it just was demo. And notice I'm binding, I got 2 role bindings referring to the same service account. They just stack onto each other and just keep giving it additive permissions. And the role reference in this case is a regular role, not a cluster role, and it's the dashboard demo. And it's fine that they have the same name in this case because cluster roles and regular roles, one's a cluster layer and one's namespace, so they can have the same name. And space. Here we go. And now I turn this watch back on, and I try to jobs won't work. There you go. So I try to get events to tell you more about pods. Start having at it. I could go in there and just add. In fact, that's probably a quick demo. Dash namespace equal demo. Edit role dashboard. What do I call that? What is that? I don't know. Oh, created that of the root. So if I go in here and add events, save that. It's just a live edit on the cluster. And go to jobs, go back to pods. Oh, you know what? I know what's going on here. This is coming in as the default dashboard. I didn't delete my old dashboard. So I've got 2 ingress rules in 2 namespaces. Default comes first before demo. And so it's stopping us. Let me just should clean this up after my last. There we go. Give that a second. The ingress controller takes about 15 seconds to stop coming from the. There you go. So now it's coming from the source account demo dashboard. Well, live demos, we do. I figured it out, but not worth figuring out. That's, you essentially get the idea. I got it. Edit. Oh, give it with access to events. I'm not gonna figure it out. It's not interesting to watch somebody debug that, but you get the idea. I'm working through it here. You see how I'm like figuring out where it's coming from. I was able to even see that, oh, this dashboard I'm going to is actually hitting an ingress rule early, going to a different namespace, which is why the binding that I just edited didn't work. So it's really kind of a powerful way to debug. The one thing that I do want to show that I thought was really my last thing here is using this to figure out what different the controller is doing. So I'm going to do a log, and instead of this whole V1 thing, I'm going to look for Nginx demo, and what I'm going to do is create a cluster role binding. Run a Nginx demo, image equals Nginx, and you'll notice here, if I scroll back through all of this, this is a cool way to see what did stuff. So I did a kubectl run, which just makes it a deploy, right? I'm just making a deployment called Nginx demo, kubectl, but that kicked off a ton of things, right? You're going to see, for example, let's see, here's the deployment controller, saw that a new deployment got added. The very first thing actually should be my hosting here. I don't know what that is. The deployment control saw that Nginx demo exists and did stuff about it. Here he is updating. You can see it fall through to the schedulers doing stuff with Nginx demo, the replica set controller, because deployments make replica sets. So you can. This is a really cool way when you combine the RBAC with the service accounts in the controller that tell it per thing. You can really figure out, like, we had a problem with ELBs where we suddenly ramped up our API traffic like crazy, and some of the kubelets timed out connecting to masters, and masters couldn't see them, so they deleted nodes, and we had stuff happening in the cluster that we weren't doing, and we couldn't figure out, like, Kubernetes somewhere is doing it. And this, when if you were to go through and say, like, oh, we want to find what happened to this pod, you look throughout all the pod, you see exactly every part of Kubernetes that touched it. I went so far as to make a separate, when I give credentials to our devs, I give them one user. And then if you're SSH onto the box, you actually, there's no unauth port, which is not normal for Kubernetes. Normally there's a port 8080 that you just get to, and the 443, which is off. And I said no unauth. So I can actually tell if someone got onto the box and was doing something, or if the remote admin was doing something, or if Kubernetes component was doing something, which is really useful if you're like, who deleted this? And I can go find out exactly who. And if it's a piece of Kubernetes, like the replica set controller, that you know what code to dig into or what to report and say, the replica set controller deleted my pod, why? And it gives you more insight into all the inner workings of, like, what's touching what. So, you can see it, like, just me doing one run kicked off a whole slew of actions. Every time that the pod got scheduled, or a kubelet reported that it's running, or all these various pieces, you can really track them. You think one API call is one thing, but it kicks off a ton of stuff. So,
how would you tail those audit logs in Minikube? You're just trying it out.
That's a good question. I have not used them in Minikube. I think you can tell them just to go to standard out, and then you'll get them along with all your regular API server logs. They'll be mixed in with the API server logs, which are super ugly, but you can scrape them out by looking for the context.
Okay.
Or you mount a volume and you tell the API server to put in that volume and you just get them out of there. We haven't used Meetup a ton, but I don't know how you do it. So here's some links. Except docs are really good. So if you really want like more detail, like how do I say all services in a namespace? How do I say this user, that group, and what these resources, and track down all the detailed information you get from there. And I got my GitHub. So that's everything I got. Do we have any other questions? Like,
So try to understand the possible or typical use cases, like, so wondering, let's say very particular namespace, you would like to have set of user only visible to them or something like that, and it is possible to do that? Like, okay, you just really limit those group within this namespace for certain API or some stuff. Okay, this is your world only, something like that.
Yeah, I mean, my use cases so far have been a lot of the Kubernetes core components, right? Like kubedns or various monitoring systems, stuff that you put into the cluster that actually tries to talk to the cluster API, but you don't want it to just have full access, right? So I just implemented our Datadog integrations with our clusters, and Datadog needs to talk to some things. So every single node in our cluster runs a Datadog agent container. And it has to talk to the Kubernetes API to get pod information and nodes and all of that stuff. But there's no reason on this earth that it needs to look at our secrets, right? So without RBAC, if somebody puts something into anything you're running to try to hit the API and just exfiltrate stuff, it would work. So my use case is like, I want to make sure that all the things that I'm running, if they really need access to Kubernetes API. Most of them don't. So the best thing you get from RBAC is you get zero access to your pods by default. So, when you just go run someone's container in there, it still gets API credentials mounted automatically because it gets a default account, but they're absolutely useless by default. So I think the biggest use case, even if you don't care about the rest, is lock down your normal namespaces. Because otherwise you run someone's code and they've got credentials and they can do anything, which is, I think, that was the way it was. They designed it that way from the start, looking forward to RBAC. So like since version 1, that's how it worked. And they haven't been willing to turn off that stuff because they're like, no, we want to go towards having this always be there from the start, and then we'll figure out how to really authorize it later. And like you can, yeah, go ahead.
I was just going to ask, can you do things within the namespace? So you had the cluster and then you had the namespace, but can you do things like match selectors or labels or something to say, hey, there's two applications that wouldn't be in the same namespace, but I want those devs to only see access to their application versus...
Oh, that's a good question. I have not looked into doing, I think you have to go by resource name right now. I think it's...
By resource name.
Yeah, but you can glob. Don't quote me on that. Don't check the docs, but I assume you can glob, in which case you can probably figure out a way to make it work. But I didn't, in all the examples I've looked at, I've never seen them do it by.
So what you're saying is we're doing it wrong.
So yeah, you can do straight by name, right?
Yeah.
And absolutely, like in Kubernetes system, we run our Datadog agent Kubernetes system. It needs one config map to do its job, so we give that one. But if you really need to say like, just get in, you probably want more namespaces in that case, right? Rather than just put them up and say, sure, you can see all your stuff in yours.
There's an open issue for that.
Is there really?
Yeah.
That'd be cool. You can also, we talked about it before, you don't have to use RBAC, you can do just lock it down. If you just want to do like a default lockdown of all the default service accounts, you can use like the webhook auth plugin, and you guys use that, right? Where you run a service that just denies everything and locks it down in a kind of a cheaper way. I think for most people, turn on RBAC, put that first cheat document on there that gives Cubase system access to whatever, and almost everything's going to work, unless you have, because most of the things talking to the Kubernetes API, like directly, or you have something that's doing it, and you really know. But they're like the good options.
So
So have you seen any, I imagine there are going to be some projects that are going to spring up that, put a GUI on it, or
Yeah, I think
some sort of a way of seeing hierarchy and all that type of relationships.
I think the dashboard has plans for that. I've seen mutterings on the emails that they're planning on adding that full RBAC control to the dashboard.
And how do you lock down the dashboard?
We lock down the dashboard with whitelisting and basic auth on the Nginx ingress controller because it doesn't have its own. So you have to be in the right network with the right password. We use the Nginx ingress controller for a whole lot. So something interesting. I'm up here just talking. Network load balancers just came out in Amazon. So I know we talked about, a few meetings ago, we talked about the ingress controller, proxy protocol, and all that stuff. Amazon now has a version 2 of load balancing. They have the application load balancer, which is their actual layer 7 HTTP stuff, and they have a network load balancer, which is a transparent proxy for all of your connections. So there's no proxy protocol. So if you've been wanting to make your ingress controllers work or get into it, you want to not know the actual source IPs coming from the internet into your controller for whitelisting or whatever. It's out there. It's pretty cool. It's mostly super scalable, fairly mobile. Yeah. Anything else? Do we have more?
In terms of that log analysis, I think definitely it's useful. And one thing, in our case, in our environment, we kind of dump out all the log into Elk stack. And when you use Elasticsearch and indexing is fully automatic and you can really deal with easily, right?
Yeah.
Rather than grep or something, right?
Yeah. The grep is just really
Yeah, I understand. But the thing is that I'm just wondering, the Kubernetes community itself try to providing its own kind of logo analysis kind of tooling stuff. I'm just wondering.
So like I said, this is the default output of the log, the audit log option. I have not dug into it, but I know there's a bunch of advanced options you can pass. There's a special flag, and you can do all. And so there might be some that say just put them on one line. The biggest, this is, if these lines by themselves, if they had the response right in there, that'd be like the easiest thing in the world to split into whatever. Key value pairs, you just read it.
Yeah,
that's good. The only problem putting it into Elk is having something that knows how to find these two and put them together, right? These two lines, because you might get lines in the middle. You need to get a request and wait till you get a response matching a need, stick them together, and send them as one, so you can really get useful. So you just put these in there now without any sort of combination, they'd be kind of a pain to deal with. I really wanted to, at the end of the live demo, I was like, see if I could find some sort of fluid D thing, because we use that for gathering everything. We set it in different places at the end, but it's all fluid D for the actual log parsing on the nodes and the masters. And I couldn't find the fluid D plugin that was already out there to just pair up two entries. You could do it. I've written a Fluent D plugin for Sumo before they had their own. And it's really easy to read all the lines they come in and store them, match it up. So maybe that's something. Honestly, it's probably something I would always write at some point because I want to put these into our logging system, and I don't want the end logging system to have to care how to match them up. I just want good events to go out there. To be something we should have at some point. But I don't know how you not already have something out there that pushes two entries together. It's multi-line, but this is different because you might have this line, another request, and then the response. So you can't just do multi-line matching, which is interesting enough. That's what is happening right now. If you look at the Fluent D official repos for Kubernetes, where they provide some that are already out there for Fluent D parsing, they just slurp these as either or and call it good for multi-line. And they're counting on them never being interrupted by another entry, which if you have your request come in and it takes 10 minutes to process, it's not work. Right? Your response is going to be way later.
Have you looked at anything for open tracing, anything like that? Theoretically, that's what's selling it, but if you want to do it before it gets any of those other systems, it might not work for you.
Yeah, I guess you're right. You throw this in there and you can open trace them together, but here's a response, here's another log. It's not none of the logging systems like that everyone's using already, Elk, like Sumo, they don't know how to do that yet.
In my talking with the Elk guys, they didn't really care. Asking the question to a lot of the open tracing various implementations, they're like, oh yeah, we can go to your Elk stack and ask it, and then aggregate results out of that. But,
yeah, I mean, it seems like the cheapest way. I know there's probably a reason they did these separately, right? So that you know someone's coming in and not have to wait till they actually finish to get the answer. But if you were willing to accept those trade-offs, I haven't looked. Maybe the advanced options have a single line. You say just don't log until you get this. Yeah, I mean, like so we've been using RBAC for a year plus. Alpha really is not good. So I strongly encourage you to go look at it. I think it's a default. What you'll actually find now is it's been around long enough. Almost everything that you go to use that needs access will just give you the YAML. They'll say, look, we need like Kubernetes, like for this to run Kubernetes, it needs to talk to the API server. Here's the documents that define what we need to do. You just create it with, you know, when things give you a folder full of YAML files, they're role-based stuff. So you don't usually need to craft them on your own unless you're doing special access. You're just deploying a lot of like Helm charts and most of the time now. It's been around enough that it's all.